like a 700.
Anyway, okay. So then let's finalize that one. Okay, easy. How to take out this? Okay, decide. Lock. So next time you easier can just go there and put the image. So normally for good image quality, that I would prefer the to say the 9 average, 60, n equal to 60, or scan speed is about 3. But it's also very subjective to your image quality itself. Because if we go to the help, it says the user manual. You should read out the menu itself. But generally, I'm going to look at this called Guide to SCM Operation Parameter. So for conducting sample, the general imaging condition for normal daily work, the routine job. UHD suggests 20 kV. With the higher UHD, higher resolution. While probe current 200 picoampere, while work distance about 15 mm, while this is the aperture hole. It said, 30 micrometer aperture. So what we are using, the only difference is that we are using different saturation voltage. Well, if you
sorry, there's a bit underneath there. The filament sets along the right line.
Here.
Have we been told not to do that?
Why?
That's what my dad wants.
No, you can do that. You see the difference is that you will drop the filament current. Now my beam current is 100 microampere. It's go to 30. You can still get a reasonable image, but you will longer. Yeah, but you will get a longer. No. I did not focus it yet.
Oh, right.
Yeah, I mean, no. I haven't really focused it yet. You should get a. Now I'm talking about the signal to noise ratio. Now it shouldn't be any problem as before. The only thing you drop, or only thing you lose, is the probe current. It's a beam current. Of course, you will lose a bit of the resolution, but it's a trade-off. You want a longer lifetime, you got to sacrifice something. So whether you want to do that or not.
I see that the image is not as clear as the...
Yeah, I mean, you will lose. Sure.
Yeah, he's at 25k. 26k. At the other day, he's totally alright.
So yeah, whether you want to do a long filament lifetime, but I mean, tungsten one, you don't really. I mean, one tungsten filament is not costing too much.
If you're not doing it, guys.
So that is so this is one called filament current to saturation point. So normally I will forget about it. I will suggest that because, sorry, can I use this paper for some other approach? So for tungsten filament, because you are filling up filament current, then you're supposed to have how we say the emission current, how many current you can emission out. Normally they will have two peaks. This is what we call the peak 1 position. This value will normally happen about 2.5 ampere. actually your setting a bit low. You may go to actually already 1. Well, then your saturation a bit. Then you will go to another peak point. It's about 2.7 ampere. Then the image won't be any sharper, any brighter. So you know this is the saturation point. Saturation point. You look at this point. So, what it's telling here is that you go to the first peak because it's keeping up smaller current. You got a longer lifetime. But if you hit that larger, then you get a better resolution.
I was always taught that you go to the second peak
Yes.
and then you back off a bit.
Then yeah, it's another way it's another way you do it. Yeah. Then if you want to do EDX, you see that you will suggest you to how would I say a larger probe current, 1 nanoampere. And the work distance has to be, of course, depends on the detector position. Well, if you want to go higher resolution image, then you got to go to higher acceleration voltage and the much smaller probe current. The smaller probe current, the probe current is very related to. Let's go to the exam. We have the spot size. I change the spot size, I'm changing the probe current directly. The smaller probe size, the smaller the probe current I have. If you want to go to higher resolution, your small, let's say your spot size now is, let's say 100 nanometer. This is how the SEM is like, how it's scanning over all the areas. This is you have some feature. These features are generally okay because they are very large, few hundred nanometer. So this small probe, they're scanning over them, they can differentiate them. But if you have a larger probe current, a few nanoampere, your spot size is much larger, maybe few hundred nanometer, and with the size of the spot size, the size of the spot is already quite comparable or even larger than your feature. Then there's no way they can get the good image. So that's why over the user guide, it tells you that you want to have a high resolution, go to a smaller probe current. Maybe 10 picoampere is quite small. Normally I go to maybe 50 picoampere, then you still get reasonable resolution. Reasonable the signal to noise ratio, because now it's very noisy because I dropped my probe current a lot. If I really go to 10 picoampere, it's very noisy. So that's why it's telling you got to cycle a longer time, 1.3 minutes, about 3 or 4 times longer. Then during the scanning, just now I tell you go to 9 average, n equal to 60, the scan speed 3. But now over here is not good enough. You got to go to scan speed 5. Yeah, to have a reasonable resolution. So okay, I mean, why not that we have a try to get a slightly good image quality. I go to 20 kb, I'm not going to 30. For probe current, I go 50. You want to get a good image quality, you want your sample to close to your column. So the image is much noisier than just now. But over the detector, you see now I'm using the, look at the SCM here. This is the current. This is the Oxford EDX detector. You see here, this one is the one we call the SC1 detector. Out here, they have some cage. You can apply a bias voltage. The connector bias voltage. You can trap the electrons. You apply a positive voltage, it's going to trap the electrons to this detector, then be detected. My range can apply as high as 400. So apply a larger value, you can trap more electrons. You may slightly get better signal to noise ratio. This is connector bias value. Is to changing the bias voltage of this cage. The bias voltage of this cage.
So it's pulling the electrons towards it. So it's pulling the electrons.
Yeah. So you were setting the value. We are setting about 300 to 400. Again, I'm going to a smaller magnification first. Then I get a big picture. Then I need to do normally I will do a wobbling, but not. So it's not that bad for this one. Just slightly a bit. So you see the stimulation is come out. Oh yeah, another thing that is every time you see that I will click this called reduce area scan that is on the hard panel, because you go that one, you will rather than refresh the whole screen, it will be refreshing only the area that you are scanning. So which is very easy that for you to do the focusing job, faster scan refreshing time. Just now I don't see much because I'm at quite low magnification. Now I see slightly a bit. I need to adjust it. it's about there. Then we disable the wobbling. Go back to the image. Correct again do the focusing and the imaging correction. Shouldn't bring my phone cover because my phone cover is a very small size phone cover. It's more useful for the field emission SAM. So you see wow, very low. Yeah, you adjust always from the lower magnification. See all the distortion. Then you go to at this signal to noise ratio, you may probably want to go to a slow scan speed. The whole cycle time about 1.3 minutes, and then you get a reasonable signal to noise ratio image, and then you click the freeze. Not every time that you'll be very satisfied with all the brightness that or the contrast you have for your image, and particularly you want to looking for certain feature. So you need to do some tiny adjustment. For example, we have that's why we come up with something called lookup table. You go to the edit, click the display lookup table. You click this gamma. Then you are allowed to adjust the brightness and contrast value even during the scanning or during the image. Then you can, this is more unlike this kind of contrast. You can adjust the gamma value, the brightness value, the contrast value. So that is one, it's quite necessary. Sometimes, time to time, we will need to adjust it. The good